The International Solar Energy Society is a non-profit, UN-accredited membership NGO. The ISO's vision is to achieve 100% renewable energy for all, used efficiently and wisely. We represent a diverse membership of academics, researchers, energy practitioners, consultants, students, businesses and advocates. ISOS works together with like-minded organizations from countries around the world to advance the renewable energy transformation. By becoming a member of ISOS, you are supporting the 100% renewable energy movement, so we do encourage you to join our society. The presentations and recording of this webinar will be available for 24 hours on the ISOS website. After that time, we will post them to the ISOS members area. If you are an ISOS member already, please log in to your account and click on Members Area in the top level menu and you will already see the library of webinars. If you are not a member, please visit our membership page and we do encourage you to sign up. That's join.ises.org. You are welcome and encouraged to ask questions at any time throughout the webinar. To ask a question, select the Questions pane on your screen and type in your question. Please specify who your question is directed to. Questions will be addressed after all the presentations in a Q&A session. We would also like to encourage you to use the ISOS discussion forum on LinkedIn to continue the Q&A and the discussion even after the webinar has ended. At this point, I would also like to give out a special thank you to our webinar sponsor, Savo Solar. Mr. Maxime Viau will tell us more about Savo Solar and the company after the webinar presentations and before the Q&A session. In the meantime, please take a look at the Savo Solar brochure provided to you as a handout in your webinar control panel. Through sponsorships, donations and also the support of ISOS members, we can continue hosting these free webinars for you. For more information about becoming a member or sponsor, please visit our website www.ises.org or get in touch with us via email. Our moderator for this webinar is Mr. Riccardo Battisti, the coordinator of the Intelligent Energy Europe Smart Reflex project. Riccardo has also been the main driving force in the organization of this webinar. So a real special thank you to you, Riccardo, that this webinar has been made possible. Now I'd like to hand over the floor to you.
Yes, good afternoon, everybody, also from my side, and thanks, Joanna, for the introduction, but of course, many more thanks, I would say, for the possibility you gave us, the project partners, to organize jointly this webinar. As Joanna said, I am coordinating this Smart Reflex project, and I work for the consultancy company Ambiente Italia in Italy. I don't want to go into details of this project. I just want you to show the web address of our website, project website, which, by the way, has just been renewed. So you find, let's say, the main project results on the website now. And I would like also, in the next slide, to show you the final event we will have for our project. We will be at the end of November in Kolding in Denmark. We will have a workshop and 2 site visits to renewable district heating and cooling plants. So you can find, again, on our website the program for this event, which is free, and so you can register directly from the website. Again, let me thank you, ISOS, the speakers, the sponsors, Savo Solar, all the Smart Reflex partners, and also, of course, all you participants. Coming to the agenda, we will have 3 main presentations, and I will describe it as soon as I introduce also the speakers. Then we'll have a communication by the sponsor, and then, as Joanna said, a Q&A session. So I would like to start now without further introduction. The first speaker we have for today is Per-Alex Sørensen. He has more than 30 years experience within district heating, energy planning, energy efficiency and renewable energy projects, not only in Denmark but also abroad. And his experience covers both aspects of energy planning, design and implementation of a renewable energy system, mostly as project manager for projects involving companies and very often also local work groups. And he's also chairman of the Flex Energy cluster in Denmark. He's of course also one of our Smart Reflex partner. He comes from the company Plan Energy, and he will talk about cooperative companies running district heating grids, reporting about the Danish experience. So, Per-Alex, I will give you the virtual floor, let's say.
Thank you, Ricardo. And this first slide, that's just to introduce myself and one of my colleagues. What I will Can you hear me?
Yes, we can.
Yes, Per-Alex. Yes, go on.
Okay, because I think I had a break. Well, first about district heating in Denmark. 65% of all households have district heating, so that's quite much. And it's also including individual houses. 54% of the heat demand is covered by district heating. But normally people think that it's most cooperatives, but actually 70% of the heat demand is covered by city-owned utilities because that's the large ones. And then we have 340 user-owned cooperatives covering the last 30% of district heating. And the history of that is we started with waste to heat in 1898, and then coal-fired power plants was the next step in 1903. But when we came to the 60s, there was a lot of individual houses heated up with coke and peat, and they had to change to something else because they wanted a higher level of welfare. So they had to change to oil or district heating. And in that case, there was private companies going around and organizing district heating instead of individual oil. So that was the first way of user-owned cooperatives. Then natural gas was introduced in '79, and that was in the beginning as individual systems. But in the 90s, the gas companies find out that they could sell more gas if it was combined heat and power plants. And that was the second wave of user-owned cooperatives. And nowadays we are converting individual gas to district heating. The framework for all this is that we have a law of heat supply, and we have a law of planning. I think everybody has that, but not maybe the law of heat supply. And then we have a law of environmental protection. That's also normal to have. And we have in Denmark made several strategic analyses of what kind of heating and cooling system is the most efficient seen with the national framework. And it shows that district heating is feasible. The law of heat supplies was introduced in '79, and that was because the natural gas was coming in from the North Sea, and they wanted a market for the gas. So actually Denmark was divided in market for gas and district heating and individual oil. And then, as I told you, after 1990, these CHP plants came, and the heat planning actually went from the municipalities to the utilities, and now it's coming back to the municipalities, so that they again takes more care of the heat planning as a part of their strategic energy planning. We have a rule for non-profit for district heating companies, even if they are owned by the municipalities. It's non-profit, so there's same rule for everyone. And if they want to change something, they have to get approval by the municipality, and they have to calculate if it's feasible or environmental a better solution. So that's the conditions overall. For the plant operation, these cooperatives, some of those are very small, down to 100 houses, and some are very large, up to 10,000 customers. Normally they have their own employees, and they solve all the daily problems. And then they have the Danish District Heating Association as an overall problem solver, because they have consultants where they can answer questions. If they have to do larger works, they will make a call for tender for entrepreneurs, and if they really need to make a master plan and and they need to have tender documents made, then they will use consultants. But they don't use consultants more than they really need. They very often call the neighbor plant instead of using consultants. If they sell electricity, they use balanced responsible companies, and they have a very nice financing system, because the municipality can give them 100% guaranteed loans. So if they want to make, for instance, a solar plant, they can have 100% financed by municipal guaranteed loans. Why does this work? Well, we have a long tradition for having cooperatives in Denmark. It's from the farming sector with dairies and abattoirs, and from the retail sector and water supply sector. So there's a long tradition for that. And it's a limited risk to be in such a company. And what the advantages are, it's transparent. So because there's a general meeting and all large decisions are approved by the general meeting, there's confidence, because everybody knows normally at least one person in the board, and there will be ownership, because people participate in the general meeting and they are informed about new projects, and there's maybe a process where they are involved in the project. So they have ownership to the system. There's another advantage by the non-profit. One is, of course, that the utilities do not pay for other things than heat. But also, if there's a good idea by one utility, they will not keep these ideas by themselves. Normally they communicate very fast to other utilities, because there's no idea in keeping ideas in-house if you have a non-profit company. What happens now is that some of the utilities are too small, so they start cooperating with larger utilities. Then I have a small part of starting such a plant. But normally we are not starting new district heating. It's normally a part of an existing system today. But if we should start, and it's done somewhere in Denmark, then it's part of the heat planning to find out where district heating is more profitable than individual heating. So that's the first step. And the next step is to contact the customers, the people in the area, to make a working group. And it has to be made very quickly, and it has to be made so that everybody can find someone they trust in the working group. So this is just an example of how to calculate in an area. The blue is existing district heating, the green is individual gas that could be profitably converted to district heating. So it's part of the heat planning for this is Horsens municipality. Step 3 is to make a business plan. We have to have a basis for decision making for the investor, but also for the municipality, so that they can see this is feasible, and for the consumers. And then if we have a business plan and it looks good, then we have to start the process getting the consumers connected. And that's normally in an information meeting, and then after the information meeting we make contracts. And when we have reached a certain number of contracts, we will start the project. For the business plan, it has to cover all the risks. So the different heating solutions has to be calculated. We have to find a place for a district heating plant. We have to show how it's organized and financed, and calculate the alternative way of supply, and so that we can compare that this is the most feasible way of doing it. And it's very, very important for a Danish customer that they can see that this is the cheapest way. And it is normally the cheapest way if you are in a city, because the common solutions are much cheaper than the individual solutions. For instance, for solar thermal, it's a factor 5 cheaper. Then there has to be a time schedule and discussion on possible barriers, and there also has to be a draft consumer contract and statute for members. This is just to show that for each project there's a break-even for connection. You have to reach that. And in this case, this break-even is, I think, 65% of the consumers. When they have said yes, then the project will start. Now there's a little pause because I think the next slide will wait a bit. I don't know why.
Okay, Per-Alex, I use this opportunity of this short break just to remind the audience that questions can be posted directly in a question box. So you should have in your control panel of the webinar tool a question box, so you can use this box to directly post questions. And I just remind you to also specify the speaker whom your question is addressed. Okay, but Alex, if the presentation
actually it will not change, so I have only 2 slides left. So the last steps, that's a call for tender and final contracts, and then the project will begin, the implementation will begin. And of course such a process costs money, and in the 60s it was private companies going around and a lot of voluntary people. And in the 90s it was actually the natural gas companies who financed most of this process. Nowadays it's difficult for private people to do it. That's the reason why it's very often an existing district heating utility who runs this project in a new area. So I think I have to stop with this, and actually in my last slide I had also a commercial for this workshop in Kolding the 24th of November. So I'm sorry for this not working, but I couldn't do anything about it.
Thank you, Per Alex. And I just informed the audience that, as said also by Joanne at the beginning, you will find also the full presentations. So no problem if we miss just these 2 slides, and one of them was on Kolding, so we already saw the promotion of the event, so no problem. Thank you, Per Alex. So I just remind you again to start thinking about questions. And I will now present the second speaker, which is Oliver Midaner. Oliver is working as a scientist for Solites, which is a research institute of the company Steinbeis for solar and sustainable thermal energy system in Stuttgart. He is a mechanical engineer, graduated with focus on energy systems. And at Solites, he's working on various national but also EU-supported projects. He's working also in smart breaklets, by the way, in the field of know-how transfer and market introduction of renewable energies in the heating sector. And the focus is on integrating large-scale solar heating plants and other renewable energy sources and thermal energy storages in district heating system. And with Oliver, we are moving to Germany to hear about what is happening there from the point of view of small district heating grids and this birth of the so-called energy village. So please, Oliver, the floor is yours.
Thank you for the introduction, Ricardo, and good afternoon also from my side. After hearing some interesting information from Denmark, I want to add in my presentation some input from Germany, as Ricardo already said, focusing on the state of Baden-Württemberg, which is in the southwest of Germany. I want to start with the frame we have in Baden-Württemberg, looking especially on the political level. As you see in the slide, we have since about 3 years a climate protection law with quite ambitious goals. So until the year 2050, we want to reduce our energy consumption by 50%. We want to reduce 80% renewables and in some reduce CO2 emissions by 90%. As very often these political goals are quite open and don't say directly how to reach them, the Ministry of the Environment introduced about 2 years ago the so-called Integrated Energy and Climate Protection concept, and there we find ideas and also concrete strategies and measures how to reach the above goals. And one of the concepts is also developing solar district heating systems. We think this is a quite nice idea, as we have in the region some experiences with renewable district heating systems on the one hand, on the other side also experiences with large-scale solar thermal systems, but mainly in pilot plant applications so far and not so many commercial applications, and therefore it's good to bring this kinds of system more into the focus. And one of the realized systems we have is the system in Büsingen, which I want to present you today. But before I go into the details of this best practice example, I want to explain you first a little bit the motivation for renewable district heating systems from our point of view, as we don't have these big numbers as we have heard from Denmark so far in Germany. To our opinion, a district heating system is a platform, or can be a platform, for renewables and efficiency technologies, and by this it is a part of the of our aim of the energy transition we want to do for the future. We knew that it needs an initial decision for such a system that's going together with very high investment costs, but we also see the advantages of such systems. For example, you have less technical installation in single buildings, which on the one hand is good for the house owner, on the other hand, on a superior level, you are getting more independent from single decisions. Furthermore, some of the heat sources that are described on the slide can only be used in a district heating application when you think, for example, on industrial surplus heat. Furthermore, in a district heating system, the single installations can be realized in a better quality for less money, and you also can ensure a professional operation. And last but not least, district heating systems can cover a broad field, beginning from small districts in cities over the supply of whole villages until the supply of really big cities by district heating systems. In my presentation today, I will concentrate on the solutions for villages, and as you see in this pictogram, there are the solar thermal collectors, which should be could be one part of the solution. Therefore, I prepared another slide to show you in a few words the state-of-the-art of large-scale solar thermal systems and their advantages. First of course, it's an emission-free and 100% renewable technology, which is mature and market available, and also available in points of view that a solar thermal system in principle can be installed everywhere. Of course, you need areas. Capacities are up to 100 megawatts, especially when we look on the Danish systems, with solar fractions of up to 50%. And it's a technology that allows stable heat costs, also in Germany, of about 50 euro per megawatt hour and below. And due to the fact that the heating market is changing at the moment, we have shorter running times of CHP systems, there's also a new opportunity for solar thermal systems in district heating, especially during summer times. Okay, coming from this more, let's say, superior view, back to the example I want to present you today. The energy village of Büsingen, which is a village in the very south of Baden-Württemberg and at the border to Switzerland. There, a couple of years ago, the citizens, together with the mayor, had the idea that they want to cover a significant share of their heat demand by local renewable energies. And the solution was to go for a district heating system. In contrast to the cooperative model we've heard in Per Alex's presentation from Denmark, they let the company Solar Complex realize the system. So Solar Complex planned, built, and is now also operating the system since the year 2013. Solar Complex, they call themselves a regional renewable utility that realizes renewable energy projects in the region of Lake Constance since, let's say, more than 15 years. By this, obviously, the citizens of Büsingen couldn't get involved in the operational issues. It's not a cooperative, but at least it's possible to become, let's say, from a financial point of view, especially involved by becoming shareholder of Solar Complex. In the picture on the slide, you see the heating central. Inside there, 2 biomass boilers have been installed, and in the facade, as well as surrounding the heating central, the solar collectors. On the next slide, you see the simplified technical layout of the system. On the left, 1,090 square meters solar thermal collectors. Then there are 2 buffer storages with 50 cubic meters each. Then we have 2 biomass boilers, a bigger and a smaller one, and an oil boiler in case there's no sunshine and the biomass boilers are out of order. On the next slide you see the layout of the district heating system. It has a length of about 6 kilometers with a little bit more than 100 connections, so there are residential, industrial and public buildings. The heat generation is about 4,500 megawatt hours per year that are supplied at a temperature of about 80 to 85 degrees Celsius. The total investment costs of the system have been around 3.7 billion euro. As I think the innovative part when the system was built for German conditions, knowing already bioenergy villages, was the integration also of a solar thermal plant. Here you have some pictures. In the background the facade collectors and in front the ground-mounted collectors. On the right side you see a picture of the ground-mounted collectors with the static foundation, which is quite similar to the photovoltaic open site systems we know quite very well in Germany. So these are driven steel profiles, no groundworks were needed, and as you see there's no soil sealing needed, the grass is growing around there. Maybe also interesting, some operational data. On the next slide from last year, from 2015, the yellow line shows the solar irradiation, and in the red bars show the corresponding solar yields we had in Büsingen. In sum, almost 600 megawatt hours of solar energy. In relation to the installed collector field, it's almost 550 kilowatt hours per square meter in year. The usable heat supply is a little bit lower, as the system works with pure water only, so you need during winter time some of the energy to going back to the system to avoid freezing of the collectors. So we have, let's say, about 500 kilowatt hours per square meter in year of usable solar heat. To understand a little bit better how the system works, you see some operational issues on the next slide. So during summertime the biomass boilers are switched off completely. So the supply comes from the solar thermal collectors, which saves obviously wood chips, and it avoids also uneconomic turndowns of the boilers. In spring and autumn the biomass boilers are running and are still supported a little bit by the solar collector field, and also obviously during the heating season the solar share is quite low. When we look on the solar fraction in heat generation, we have, as mentioned before, in summertime we have 100%, and when we're looking on the whole year, the solar fraction in heat generation is about 13%. This have been the slides specifically showing you the example of Büsingen. On the next slide we try to summarize a little bit the success factors from our point of view regarding the realization and organization of small-scale renewable district heating systems. Here's some points regarding organizational issues. So we think very important is to have a motivated and competent person promoting the project locally, which often can be, for example, the mayor of the village or the small town. It's also important to have a competent planner, to have a successful planning and also a project development. And you also have to be quite close to the citizens, especially when you have critical questions or critical citizens there. One idea is, for example, to put the people into a bus and bring them to another system that is successfully running, to show them how it does work. And in this context, I think the keywords are really communication, confidence, and being as transparent as possible to convince the people. From a more technical point of view, it's very important to realize the system in the best available technique. When you think about the district heating network, which will be installed for the next, I'd say, 40 to 50 years, it's really important to use system parts that are really state-of-the-art. Low network temperatures and low heat losses improve the system efficiency, and also regarding a superior look on the energy transition, it's important to use local and cost-efficient energy sources, as we have the example of Büsingen with biomass and solar thermal. We tried to sum up these experiences and more detailed experiences in different projects we worked on the topic of large-scale solar thermal plants. Within the project Solnet BW, we, or especially the colleagues from Hamburg Institute, prepared some materials, for example a guideline for funding and financing and a guideline for planning and authorization of such systems. You can find these documents on our project website, solnetbw.de, unfortunately only in German language so far. Closing the loop from the beginning of the presentation, also on political level, we have good progress in the state. The Ministry of the Environment introduced a new program in February of this year promoting energy efficient and renewable district heating small-scale systems. In a few words, I want to present you this program, as we think it's a quite good way to promote this issue. The program consists of 3 parts. The first one is funding or additional funding of municipal climate protection concepts, and by this also fostering heat planning. The second part of the program is establishing regional initiatives that are promoting renewable district heating systems and are giving advice to potential investors, to municipalities and so on. And the goal is to install in each of the 12 regions of the state one contact point that is able to answer questions and to promote the issue of renewable district heating systems all around the state. The third part of the program are subsidies, additional subsidies for district heating investments that are linked to advanced quality criteria, for example, low return temperatures, usage of solar thermal systems, and so on. So, in sum, we think let's call it the mood regarding the use of solar or renewable district heating systems in Baden-Württemberg is quite positive, and together with the funding programs, as we also have on federal level quite good funding programs at the moment, this should be taken up in activities, and therefore I have as a kind of outlook my last slide, this map of Germany showing you the larger solar district heating systems in Germany, and also when you look on the bottom left, this brownish color field, this is the state of Baden-Württemberg. The red dots show you the systems in operation, the orange ones the systems in planning, and in yellow the systems that are in preparation at the moment. And when you look at the systems, or when we look at these numbers and these systems, we hope to see, let's say, a doubling of the long-term SDH systems in Germany in the next 1 to 2 years. Of course, the absolute numbers are very little in comparison to the numbers we know from Denmark, but still we think there's a big potential for this technology in Germany, and we're really looking forward to the next years and hopefully seeing more systems emerging. That was everything I want to tell you today, and thank you for your attention.
Thank you very much, Oliver, for your clear overview of what is happening. I think you showed this example from one region, but I know that the same is happening in many other regions in Germany, so it's quite interesting that it's it can be, let's say, a good replication case. I just want you all to say thank you for the questions. We already received a lot of questions, and we will try to answer some of them, of course, in the Q&A session. And as I realized that some people just joined the webinar, I just remind you all that questions can be asked by using the question box that you all have in the control panel. So we have now the last presentation, which will be held by Per Christensen. Per is an electrical power engineer, so he used to work with the electricity production and distribution sector. But for us, of course, his most important role was the one as director of Broedstrup District Heating company in Denmark. He has worked there for, I guess, 11 years or something like that. And this plant was really the first district heating plant combining large-scale solar thermal with cogeneration units, so it's quite interesting. Now Per is working with his own consultancy company where he's assessing applications for public financial support for energy projects. He's also consultant in general for energy project and for municipalities about strategic energy planning. And he's also representing a cooperation of district heating companies and municipalities in different contexts. And he also represents sometimes in some project the consulting company Plan Energy, for instance in the project SDH-P2M about solar district heating, and also the Danish Nature Agency in different projects. The focus of Per Christensen, of course, will be the plant he knows best, so the Broedstrup District Heating plant. So Per, the floor is yours.
Thank you very much for the introduction, Ricardo, and good afternoon, everybody. Yes, I will tell you a little story from Denmark. It is not a fairy tale, it's actually a story from the real life. I hope I could make a shift here. Okay. The question is, where is Braedstrup District Heating Company, and where is Denmark, for example? Here we have Europe, here we have Denmark in the middle part of Europe, and here we have Braedstrup situated just in the middle part of the western part of Denmark, named Jutland. Braedstrup is a part of the municipality of Horsens, and to talk about what happens in the district heating companies with the progress we have heard Alex, and I will just repeat quite short. We see that Denmark to the left, where we in the mid of 1980s have a very centralized system with very small and very large combined heat and power systems. It was based on production of electricity and as a secondary producing heat to district heating companies. But as we heard from Alex, the government said that we had to have a more decentralized structure, and therefore all the district heating companies got the message to convert from, for example, coal and oil to natural gas. And on the left-hand side, we see the new structure with a lot of small district heating companies, some of them very small, with some few hundred customers, and some of them quite large. But to focus on Braedstrup District Heating Company, it is a typical Danish cooperative owned by 1,550 customers. That means the cooperative in the Danish way means that the customer, the consumer, and the owner is one of the same person. Production in Braedstrup is approximately 50,000 megawatt hour heat and around 20,000 megawatt electricity. The last is absolutely depending on the price of the electricity, of course. And then they are administrating some water customers also. And here we have all the customers in the upper side. This is all the owners. We have the general assembly where all the customers have an access and a vote. And the general assembly is selecting the board. In this case, there's 4 members which is elected by the general assembly, and 1 member of the board is from the municipality of Horsens. And then we of course have the management and staff. Again, the highest authority, the general meeting. We have at least one general meeting once a year, and then there can be some information meetings. For example, when there is introducing some new technologies. In this case, for in 2007, solar in combination with the combined heat and power. And here we saw in 2007 there was 122 votes for the proposal to build a solar system in combination with the combined heat and power. It was the first time that happened in Denmark, and some of the people in the General Assembly was a little insecure because it was the first example. Some of them said, why wait and see what happens with some other companies to learn about their experiences. But they became convinced some companies have to go to be first mover, and in this case it was Braedstrup. But you can see there was 5 votes against the proposal to build a solar plant in combination with the combined heat and power station. But in 2007, which we suggested an extension to the 2007 project, and there you can see that all of the votes was for the proposal, and everybody was very glad for the 2007 project. I think rather many inhabitants in Braedstrup was very proud of the plan. And here you can see all the guys from the General Assembly. You can see the atmosphere was quite good. We made a plan for how to be a very cheap district heating company. We said that natural gas and other fossil fuels must be phased out in the run of time, of course, not just here and now, but because at that time, 2006, natural gas was quite expensive, and it is so in Denmark that at that time the taxes on natural gas was in the same amount as the price for the natural gas. So we had to do something. And then the plan was to make some long-term investments in renewable energy technologies, and we thought that at that time that it was very important to link the electricity and the district heating technologies together. to ensure an optimal use of all the electricity from all the windmills in Denmark. We know it today as smart grids. So a long time plan for Braedstrup was to make 50,000 square meter solar, which is equal to 50% of the heat production, and the rest could be, for example, biogas. Here we have the 2007 project, the 8,000 12 square meter. Today, you can see it is a very, very rather small plant, but at that time it was a huge, big, large plant. But so is the progress. It was, as I mentioned, the first solar plant connected to a combined heat and power station. And here we have some very stable employees, some ecologic grass clippers, and we have a very nice summer day, you can see, in Denmark. And here we have Broedstrup District Heating Company in Brixen, Legoland. Some of you have seen it. The 2007 project, some data, a production of 3,600 megawatt hour heat from the solar per year, which corresponds with 9% of the production demand. And here we have the investment and the payback time. You can see we got some grants on 1.4 million euro. It is so in Denmark there is no standard grants for building solar systems. But if you have some innovative plans and some innovative projects, it is possible also today to get some grants. This was innovative because it was, as I mentioned, the first in combination with a combined heat and power station. Then we built a new plant in 2012. Then we have it on the right-hand side. This was 2007, and also steel tank on 2,000 cubic meters 2007, and an existing generating system and gas boilers. And this was a new one, 10,600 square meter from 2012. And there we built also a borehole storage system, a seasonal storage system, and a new steel tank on 5,600 cubic meters. And then we built also a heat pump and electricity boiler. And here we have a simple plan. You can see here, you can see the engine generating system will produce electricity to the grids and heat out to the customers or to the accumulation tanks. Of course, this is only running when the electricity price in the stock market is rather high. First priority, of course, the solar system, which via an heat exchanger, the energy goes direct to the customers or to the accumulation tanks. When the electricity is very cheap, we start the electricity heater. It's on 10 megawatts. It produces heat to the accumulation tanks or out to the customers also. And the heat pump, it ensures a very cold bottom in the accumulation tank and a rather heat top temperature. And when the bottom is very cold, we can put the cold water out to the solar panels to ensure a rather high efficiency. The borehole storage is it's a pilot project which demonstrates how to accumulate the heat from summer to winter. And if we look a little about this, we have the plant here, and here we have the cold storage system, and we have the pipes to the solar and out to the customers. Here we have the borehole storage, a lot of pipes, and a top of mussel shells to ensure that the heat not goes up to the heat. And here we have the shape of the borehole storage. There's 48 holes, 45 meter deep, and here we have this, and it is 19,000 cubic meter soil, which is the same as around 4,750 cubic meter water storage. The 2012 project is producing 4,800 megawatt hour heat per year. It's now 20% of the production demand, and here we have a payback time on 10 years. And it is the final plant, the plans for Braedstrup to ensure 50% of the heat demand, which is around 50,000 square meters. It is at the time only a plan. It is not realized at the moment. I have made a short business model for a new project, typical example from Denmark, with a solar area of 10,000 square meters. We have to pay for some land. I think it is rather cheap in Denmark compared with other places in Europe. But we have to use around 30,000 square meters, which costs around 50,000 euros. Then we have to have some solar modules, some pipes and heat exchanger, pumps and so on, in 1,850,000 euros. Then we have some fencing, soil processing, and so on to 50,000. Transmission pipes around 1,000 meters, 300,000 euros. Control systems, counterlink, case positioning, and so on, and total around 2.4 billion euros. And if you calculate a production for 10,000 square meters to 5,000 megawatt year megawatt hour per year, and we have some capital costs on 119,000 euros per year, and some maintenance costs calculated to 5,000 euros per year. Then we have a total production cost on 24.8 euros per megawatt hour. And it is enough for a Danish district heating company to say, let's go after this solution. My last slide shows a little about what I think is very important to see the structure for the district heating in the future, district heating system in the future. And we have made some plans in the municipality of Horsens, which also goes to a neighbor municipality south. It goes to connect the existing production places, the existing district heating companies with large transmission pipes. Here we have Horsens and we have Braedstrup, and we have solar in Braedstrup, and we have seasonal storage in Braedstrup, and we have some industrial surplus heat possibilities in south, which can be produced into the pipes, and we have some possibility from geothermal production in this place, also is planned to use into the pipes. And then we have some plans for biogas, and there we also have the possibility to inject the production into the pipes. And we have some biomass plants, and we have possibilities when we have a grid of transmission lines. We have a very nice flexibility to build, for example, solar where the land is cheap and where it is available land for disposition. And we are not. It is not so that the solar plant is going to be built near the large towns, where it's very difficult to get enough land. So this is a plan from the municipality of Horsens. And then, of course, we can make a conversion from natural gas and oil to district heating, not to build new plants in the small cities, but to connect the small cities with the transmission grid. So such a strategic energy plan is very nice to have. Then we have to plan in the longer run. And with those words and the hope to see much more solar in Europe, I want to thank you very much for the attention.
Thank you very much, Per, for the interesting presentation, and thank you all again for a lot of questions that we are receiving. So I would very quickly leave the floor to Maxime Pio from Savo Solar for a short communication by our sponsor, and thank you again for accepting to sponsor this webinar. The floor is yours.
Yes, thank you. So hello everybody. So as you said, from the company Savo Solar, so we are manufacturing the world's best or most efficient solar collectors of the moment, and we are focusing on providing solutions for medium and large scale installations, so typically district heating networks or process application and so on. And as some of the speakers before have said, that solar is providing low-cost energy production, and with our high efficiency we can have the best cost performance and long-term plan in the long term, so it will not change, and it's also emission-free. And the technology developed by Savo Solar is unique and has been awarded at the Intersolar 5 years ago for the absorber, which is a bit in full aluminum and having a direct flow in the whole surface. So that's the core of the performance of Savo Solar collectors. And we are also changing or innovating in our way of installing those collectors on the fields or on the roof, or for the connection, which is giving a different outlook for the solar fields. And as you can see on the round picture, we have already installed several large plants in Denmark or in elsewhere in Europe, and up to 15,000 square meters. So, and that's all, I guess, for now. Thank you.
Thank you very much, Maxime, also for the quick presentation, let's say, which allows us to start addressing some of the questions. Once again, thank you all. I would start, of course, from the first speaker, so from Alex. We received several questions about a very hot topic, which is the connection of district heating supply with energy renovation of buildings, and with the fact that being the buildings more and more efficient, there will be a lower energy density. How is Denmark facing this problem also from a policy point of view? So how district heating development policy is connected to the energy renovation in buildings policy?
If it's existing district heating areas, renovation of buildings will give us a possibility to lower the temperatures in the district heating grid and make it more efficient. And so, and often if you're in an existing area, there are limits for how low you can go if you want to renovate your buildings. So there will still be a demand for district heating. If we are in new areas, then we want to go for 100% renewable energy in Denmark. That means that you can have individual heat pumps for heating, or you can have a wood system, but whatever you have, it's normally more expensive than district heating. So very often we prepare also new single housing areas with district heating, and with very well insulated double pipes, so the heat loss in those new systems is still not more than 15 to 20% of the consumption. So, but to do this, there's always a risk that if you have very low consuming houses, that people will not connect. So very often the preparation of the building site, it's then the district heating pipes is a part of the street preparation, so that the consumers only have to pay for their connection pipe.
Okay, thank you. So it's a challenge, let's say, but it can be dealt with. Okay, I would now move to Oliver, and there are also several questions about the grid temperature, and in particular people asked about these grid temperatures in Büsingen, so this 80-85 degrees output. They ask if is it really necessary, and why, since they have to develop a grid from scratch, let's say, why didn't they think about a lower temperature grid like 60 degrees? Was it feasible or not?
Well, in the case of Büsingen, it was an existing village, so the buildings were already there, and many of them have the need of receiving a higher temperature level to cover their heat demand. So in newer buildings, as we've heard from Per Alex, it's a different situation, but in that case it was necessary to, let's say, supply them with such a high temperature level.
Okay, so the main problem was that the already existing user appliances. Okay, thank you. Per Christensen, I move to you. Just two quick questions, which are more from a, let's say, technical economic point of view. So a participant asked for which is the type of soil that is in Braedstrup that you could build this borehole storage. And the second question, which is quite practical, is what is the final price in, let's say, if possible in euros or something like that, per megawatt hour to the customer?
Yes. I didn't hear your first question quite well, Ricardo. What was the question? What was the kind of oil? It is not oil. It is pure water who goes into the...
Oh, no, sorry. Sorry, the question was about the type of soil, so the ground...
Soil?
Yes, exactly. That you were able to build a borehole storage.
Yes, soil, that's okay. It's, in this spot, it is a mixed soil between sand and some more heavy soil and some small stones also. It is not an optimum soil for the soil, but it is a mixed soil and a typical Danish mixed soil, I would say. Yes. And the second question was what is the price for the end customer? It is so that we in Denmark is talking about a standard house which is on 120 square meters, which uses 18.1 megawatt hour per year, and the price is in euros 1,500, around 1,500.
The last price is 1,268 euro per year.
Not in Braedstrup.
Yes.
Okay.
It's very cheap. It's very cheap. Yes, yeah.
Okay.
Okay. Thank you very much also for starting the discussion about that. So, Per Alex, since you talked, I take the opportunity of asking you one more question, which is what are, let's say, the main challenges of shifting partially also in an existing district heating grid from fossil fuels to renewables, and also the challenges of building from scratch a grid basing on a high share of renewables?
Well, I can most talk from the Danish experiences. In Denmark, it's always the money. So if you can change to green district heating and you still don't have to pay more, then it's possible. But if you have to pay more, we always have problem with the customers. So I think the economy is the largest problem. If you look at the technical problems, then I think if you're in the cities, then the heat sources are important, and biomass is a limited source, so I think for the future it's heat sources for heat pumps we have to look for, and also for areas for solar thermal and for storage. So the combination will, in future systems, that will be heat from heat pumps and from solar thermal and from combined heat and power systems as the backup and electricity production, and then some storages to make the flexibility in the systems.
Okay, thank you. So a very interconnected system, let's say.
Yes.
Oliver, I go back to you. There are several technical questions about using them. Maybe I just ask you two questions. One is why to use pure water in the system, and the second one is if there is a cooling load also, and if this cooling load is somehow addressed by the district heating grid.
Okay, for the first question regarding the usage of pure water, this is simply because the operator chooses in this case to go for evacuated tube collectors, and the manufacturer in that case has a system solution that is working with pure water. So in that case it's not a choice of the operator. Well, somehow it is because he chose this product, but it's depending on the product, which in contrast to many other solutions that work with glycol and water, has a solution with pure water. So in that case, this is the reason for the system working like this. The second question regarding the cooling load, no. So there is no significant cooling load. therefore the heating network covers only the heating and the space heating and the heating of the water demand of the customers of the buildings there, and the cooling demand was not necessary to cover.
Okay, thank you very much. Per, I go back to you with a question about politics, I would say policy. There is one participant which is, I would say, astonished of your possibility of setting good goals and good strategies. And so the questions are, isn't policy in Denmark influenced very much by private energy companies, or do you have climate goals which you follow strictly? And additionally, is there a kind of an association for promoting these local solar heating systems in district heating grids?
And which pair do you ask?
Sorry, I was addressing Per Christensen.
But we can combine the two pairs.
Yes.
It is so that we have some plans, some national plans in Denmark in order to get rid of the fossil fuels. And it is so that all individual oil, all oil must go out in 2030 and also gas in 2035. And very many of the municipalities is following those plans in their local politics. And of course, when you are joining the municipalities and making plans in the municipalities between the municipality and the district heating companies in the municipalities, we are of course following those targets. But there is no authorities who says, for example, you have to make a solar system. It depends of the decisions for the local district heating companies.
Okay, thanks. But Alex, do you want to add something on that?
Yeah, the targets we set in Denmark, that's the overall targets, that's political targets, and it's in our parliament. So they have a target of 100% renewable energy in 2050. And then the short time targets, there's of course organizations, that's the Danish District Heating Association as one of those. And another one is Danish Energy, that's the gas utilities and electricity utilities. They try to influence the policy, but normally it's the overall calculations showing what's the most efficient system that decides, that make the politicians make the decision. But we are a small country, so we can sit around the table and discuss those things. And even if, for instance, the gas utility, they can see that they will lose a market, they will normally obey what's the best for the country.
Okay, thank you. I would like now to come back, let's say, to more technical and economic question. What is the operation and maintenance cost? This was asked especially for the solar thermal part. So for large-scale solar thermal plants connected to district heating grid, what is your experience in terms of O&M costs? And this is addressing all speakers if you want to answer to that.
For the solar system, we have from the first large solar system in Denmark, that was in Marstal, and it was opened in 1996. we have a long time experience with the costs, and it's around those €1 per megawatt hour, which Per Christensen showed in his presentation.
Okay, and any other comment on that? If not, then I would like to ask you also about another technical question which came in, which is about the share of heat losses. I guess it's quite variable from plant to plant, so maybe I would ask Per Christensen if you can tell us about the experience in Braedstrup. So what is the share of heat losses there, and how, which measures did you take to reduce them?
It depends on what kind of heat losses we are talking about. Is it heat losses from the plant and out to the customer? It is varying in Denmark from perhaps 18% to up to perhaps 30-35%. There is nearly no heat losses inside the plant, and there is nearly no heat losses from the solar plant and to the for example CSP plant.
Okay, Oliver, do you have any figures for the Büsingen plant?
Well, the heat losses in Büsingen from the distribution network are something like around about 17%. In general, it's the same in Germany, that the range is big, yeah, from very good systems having around 10% heat losses up to systems with 30% and more. So the range is big, yeah.
Okay, thank you. So we still have time for some questions. I think many people are still interested in the seasonal storages. So I would like to maybe start from Per Christensen, asking him what is the efficiency of the borehole thermal storage in Braedstrup, and this is connected to another question which was about the heat losses from the storage.
Yes, I really think that Alex know more exactly about the heat losses because they are measured after I have left Broedstrup District Heating. But I know that I mentioned it is a pilot project, so the heat losses was calculated for a full project, which is perhaps 6 times larger than the pilot project. And my opinion is that the heat losses, the measured heat losses, is very equal to the calculated heat losses. But I think, Alex, you can give some more exact data.
Well, it's so that the first years, such a borehole storage, it's heated up and cooled down and heated up and cooled down. So if we calculated the last year's heat losses, it was negative, and if we take the year before, it was quite high. So what we can say now, that it looks like it will be as calculated, and then it's for a full-scale storage, it's around 20%. And if it's a water pit, then it's approximately the same. It depends very much on the size of the storage, but we have made storages of 50,000 cubic meters and more, and it's about those 25%.
Okay, thank you. And I take also the opportunity to say something more in general about heat storages, since there were a lot of questions about that. So you can find some, let's say, systematic information about that also on the website of the SDH P2M. project. So you just have to type in Google solar district heating, and the first site you will find is the solar district heating website, and there you will find some guidelines for these systems, and you will find also the technical and economical description of several types of seasonal storage. So I think we are almost at the end of our webinar, so I think I will hand over to Joanna for closing the webinar. I thank again the speakers, our sponsor, ISIS, again for organizing the webinar, and all participants also for the very interesting questions.
Thank you very much. And thank you to our panelist speakers for sharing their knowledge and expertise with us today. And to you, Ricardo, thank you for putting this webinar together. As you've already stated, a special thank you to the support of our sponsor, Savo Solar. We really appreciate the support you are providing through your sponsorship. It was an excellent session, and I hope that you all enjoyed it and could take a lot from it. To contact the panelist speakers for further information, please see their own contact information in their presentations, which are all available to download from the ISIS website. The next ISIS webinar is already planned and will take place on Tuesday, the 29th of November. It will focus on renewable energy in developing countries. We welcome you all to join. Please find more information on our website www.ises.org. If you use social media, we encourage you to connect with us to continue the discussion and continue to stay tuned into this very interesting topic. Last but not least, thank you to our audience from all over the world for joining us today. We look forward to welcoming you at another ISIS webinar. You may view the webinar recording in a couple of hours on our website. Please check the website. The link is posted in the chat box and also our YouTube channel. As mentioned before, ISIS members, you can log into your account and watch all the webinar recordings in the members area. If you have any comments or feedback, we welcome you to share this with us so that we can continue to improve our webinar service for you. Please participate in the survey that will be at the end of this webinar, or send your feedback directly to public.relations@isis.org. That's all from me from today. Thank you very much again, and wishing you all a great start to the day or evening, whatever time it is in your part of the world. Thank you very much. Bye-bye.